Next activity for Fire Riser Design is actually to get the component models that you will use to create your assembly. So you can either go online and find online components in Revit City, or you could even use SketchUp and bring them in if you want to. If you can find some, or Inventor or AutoCAD, for each of the components, you can do a quick search to see if you can find some pre-made models. Now, again, I'm using a 4-inch, and so if, for example, I could find a 4-inch Ames dual detector check, DC-DC, or double check, then an Ames 2000 or somebody else's, I could do that. That would be cool. But what I'm going to do is just show you create new models. Okay, so and you'll end up with a mix for your assembly. You can certainly have a mix of devices if you wish. Okay, so find manufacturers' models and or create new models for your riser components. I'd like to just show you that I created an Ames 2000 model. Okay, so oops, let's make that full size. So this is my object, right? And you can see over here that I just made it. It's almost entirely made out of cylinders, except these two blocky things. And I modeled the gate valve using two different styles of blocks. One of them went from midline in either direction, and the other one went from my center line up. And both of them had a taper, just to show different ways that I could model a gate valve. And notice these are not particularly detailed. What are you going to need in Revit? You're going to need to have an inlet and an outlet, okay, or vice versa. It's got to go one way or the other. But there will be an inlet and an outlet that you're going to hook into, and you want it to take up the right amount of space. Okay, we've done this quite often in design 320 and design 310 and 325, 328, where you're just taking up the space to make a shape. If I want this to look just a little bit more valvey, I could put a hole in it. I could put 4-inch pipe hole is actually 4.62 diameter. Okay, so if I wanted to, I could punch a hole all the way through that. I could go the other way, and I think it's 40 inches long. There we go. So I could do something like that too. I could make it look like it's got stuff around it, but it's really not necessary for a Revit model. Not necessary at all. So this is the level of detail. Notice I even just made this straight. What does it actually look like? Let's go and look at it. You can see, well, that the gate valve kind of looked like a gate valve. And the valve kind of, there's a tube and a piece sticking up sideways with a cap on it. And it has a smaller neck and a bigger body and a small neck again. But it's not really important. I just need water to go through it, and I need it to kind of be recognizable. How do I get the dimensions for it? This is all performance data, and here are the dimensions themselves. Okay, so the important thing is the overall length, A, and remember I chose a 4-inch, so I took 40 inches long, and L being 22, and that means that each of these are about 9 inches. Okay, so that's sort of how I did it. And then this dimension to the edge, center to the edge of the flange, 4.5 inches. That's a 9-inch diameter flange. And I didn't know how thick they were, so I just made something up. I made them 1/2 inch. It does not matter at all. I don't need all these little bolts and these gewgaws. I just need something that sort of looks like it. Okay? And then I just estimated this height too. So that's my work that I did on creating the new models. Once you've got them all, you do need to put them together into an assembly. Okay, for our purposes, rather than putting in different pieces into your Revit model, we're going to put in one riser assembly. So it's going to start at the bottom and go to the top, and all the little pieces parts are going to be included in it. This was one of the main focuses of Ames, where I worked, was to pre-assemble things that were tested and certified by us, the manufacturer, as a one whole integrated piece, so that the contractor just had one quick install, and they had a certified working set of parts. They didn't have to worry about matching up all of these things to make sure that they all worked together. We did that for them. And so I'm carrying on that thought and that tradition that from a point of view of an engineer, we like things to be pre-assembled, tested to a certain specification, so that all they've got to do on site is put in, 16 bolts, and it's done. Now, it's not quite that easy, but it's almost that easy. So there we go. Once you've got your assembly done in whatever you're going to use, DWG, Revit, Inventor, AutoCAD, SketchUp, whatever you're going to use, save the model of your assembly in something that can be done in Revit. That's a DWG, an OBJ, or an SKP. So there's your activity 2. Think about 4 hours would be just about right. This model here took me about 30 minutes. Okay, and that's one of the bigger parts of the model to be using. Now, I am going to keep this as a separate unit, but when I put it into my assembly, I'll put it in as this. The reason I'm doing that is I want to be able to use this later on as a tabulated drawing that I can put into my details. So there we go. That's the essence of what we're going to do in activity 2. Model individual components, and then of course create an assembly.